Hi everyone, welcome to the classroom. I am Dr. Peiris. Today I am going to explain you DeMorgan's theorem. So first I'll show you the DeMorgan's theorem and then I'll show you how to use the DeMorgan's theorem to find the complement of given functions. So let's see what the DeMorgan's theorem. The DeMorgan's theorem is written using these two statements and we use these two to find the complement of a function. The importance of the DeMorgan's theorem is you can use that to find the complement of a function very easily. So the first one says you do x or y complement, this equals x complement y complement. The second one, xy complement equals x complement or y complement. So if you look at the two statements, the or gate in the middle becomes the and each variable becomes the complement. Same thing happen here, the and x and y, the and becomes o, and we again take the complement of the each variable. So basically in the DeMorgan's theorem, the o operator becomes the and operator and the and operator becomes the o operator when you take the complement. Now let's see how we're going to use these two statements or the DeMorgan's theorem to find the complement of a function. The first one is find the complement of the following function. The given function f is a prime b c prime plus a prime b prime c. So let's take the complement. So the complement of f is written as f prime. We take in the complement of the entire right hand side. A prime b c prime or a prime b prime c, we take the complement. Make sure that you put a parenthesis when you take the complement. We are taking the complement of the entire statement. Now let's take the complement of each term. So we do the complement of the first term. Complement of the first term, a prime b c prime complement, and the plus or the o operator becomes the and, which means we just write the second term inside the parentheses. So there is and between the two terms. Then we take the complement of the second term, a prime b prime c. So we're done with that. Then what we do next is we take the complement of each term again. The first term is a prime b c prime complement. So we take the complement of each variable. At the same time, since it is a prime b c prime, there are and operator in between, so all the and operators becomes o. So the first one is a prime complement becomes a prime prime is a, then the and becomes o, b complement is b prime, then the and becomes o, c prime complement is c. Same thing we do for the second term. A prime complement is a and it becomes o, b prime complement is b, again o, c prime. So you see that all the o operators becomes and the and operators becomes o. At the same time we take the complement of each variable. This is the final answer for this question. This is the complement of the given function f. Now let's see another example. So we're going to do the same thing. We're going to find the complement of this function. So let's do f prime and make sure that we do the complement of the entire right hand side. So that is why I have the square brackets to make the complement of the entire right hand side. So we have to be careful where to start when we take the complement. So this is a times another big parenthesis. So between a and that parenthesis there is an and operator, which means that becomes o when you take the complement. So the variable a becomes a prime since we need to complement each term, the a prime, and the and becomes o. Then we take the complement of the second term. The second term is b prime c prime or bc, and we take the complement of that term. So the a prime stays as that since we already took the complement of that o. Now we need to take the complement of this parenthesis. So which means we take the complement of B prime C prime complement. The O operation becomes AND, which means we basically write the second term next to it, because we know that there is an AND operator between parentheses. The second term is BC, and we must take the complement of that. So let's continue solving. A prime O. Now we take the complement of B prime C prime term. So what is the complement of B prime C prime term? B prime prime becomes B, the AND becomes O, C prime prime becomes C. And the next one is BC complement, that becomes B prime O C prime. So again you see that the AND operators here becomes the plus, AND operator here becomes the plus in the next one. So now we have found the complement of each term, which means this is the final answer. So you must keep doing until you take the complement of each and every term. Let's see another one. We're going to do the same thing here. So we do the complement of F prime. Now again I put the parentheses A B O Z X O A prime, and then close that, and then big square bracket, take the complement. Now we do one statement at a time. So again we do work with the A and the big parentheses. So we take the complement of A, which is A prime, and between A and the parentheses there is an AND operator, so that becomes the O. Then we take the complement of the second term, B Z X O A prime, and then we take the complement of this entire term. The A prime stays that, and O. Now we're going to take the complement of this entire term. So again we do one at a time. So the complement of B becomes B prime. Now it becomes AND here, because of the O, the plus becomes the dot. Then we take the complement of the next term, which is Z X O A prime, and then we must take the complement of that one. So this is how it looks like. So it is the complement of the entire Z X O A prime complement. So let's continue. A prime O B prime. Now the next one, complement of Z X O A prime prime. So we take the Z prime, and then it becomes O. Then we need to take the complement of X O A prime prime. So we continue. A prime B prime Z prime. The next one is X O A prime prime. So it becomes X prime, then the O becomes AND. A prime prime is A. So now you see all the primes are gone, so we have complemented the function. So all the combinations of primes are gone, so only individual terms have the primes. So you cannot basically simplify A prime, it is going to stay as A prime, and the B prime stays as B prime, Z prime stays as Z prime, and then the X prime A. So this is the final answer. So this is how you take the complement of any given function. So that's all for today, everyone. I hope everybody understand how to do the DeMorgan's theorem and how to use that to find the complement of any given function. So please subscribe to my YouTube channel, Dr.Peiris Classroom, for more videos of this class as well as for other videos. And please visit my website www.drpeirisclassroom.com. In my website I have gathered all the videos under certain courses, so you can easily find all the videos for that particular class. Thanks for watching, everyone. I'll meet you again with another video.